Imagine if, to use your toaster every morning, you had to, like, walk outside in the freezing cold
Right.
and attach a wire to this rusty metal pole just awkwardly sticking out of your siding. You crank a squeaky brass knob, and then you just hope you don't get rained on while you're trying to make breakfast.
Yeah, nobody would ever accept.
No, absolutely not. You would never accept that level of friction. But, I mean, when it comes to the high-pressure water system in our homes, we are entirely conditioned to interact with hardware that honestly looks and operates like 1950s farm equipment.
It really does.
You reach down to that crusty spigot to water the garden or, wash the car, and water inevitably just sprays all over your shoes.
Or you scrape your knuckles against the brick.
Exactly. You scrape your knuckles and you just accept it.
Well, I think we tolerate it because it sits just outside the periphery of what we actually consider technology.
Well, that makes sense.
Yeah, we expect our thermostats and our doorbells to be super sleek and intuitive, but we give a pass to the outdoor plumbing because we just assume it inherently has to be this messy, neglected piece of infrastructure,
Okay, let's unpack this. Because for this deep dive, we are looking at something seemingly mundane, but surprisingly fascinating.
Totally.
We are talking about a complete reimagining of the everyday outside water faucet. And our guide for this journey is a detailed project walkthrough from Claude Taylor, the creator behind the How To Plumbing channel.
A great channel, by the way.
Oh yeah, really informative. He is taking us along as he reviews and actually installs a modernized house hydrant by a company called Aquor Water Systems, retrofitting it right onto his own home.
And our mission today, alongside Claude, is to explore how small, clever innovations are quietly revolutionizing our basic home infrastructure.
Right.
We're looking at how the plumbing industry is engineering the headache out of maintenance and turning a complex, often frustrating utility into a seamless, user-friendly experience for you, the homeowner.
But to really appreciate the leap forward this new hydrant represents, we have to look at the visceral, gritty reality of the installation itself.
Oh, man. The reality is rough.
Yeah, this source material is not some sterile laboratory test. Claude is working on his pier and beam house, and he is literally crawling on his back under the house.
With what, like a 4-foot clearance?
Barely 4 feet.
Yeah.
Navigating this cramped vertical clearance in the sweltering heat of South Texas.
Right near Houston. The humidity there is just brutal.
Unbelievable humidity. And the entire time he's down in the dirt, he is fighting a battle of focus against the background noise of a neighbor's obnoxiously loud motorcycle.
The sensory details in his walkthrough are incredibly effective. Like, you can practically feel the oppressive heat and the claustrophobia of that environment.
Yeah, you really can.
It perfectly captures why traditional home plumbing maintenance is something people actively dread.
Which sets the stage for the first major hurdle. Because Claude's old outside faucet is just a complete mess. It's wobbly, it's unstable. But to fix it, he has to completely dismantle the old system. So he cuts off the main water to the house, turns the outside faucet on to bleed the pressure out of the lines,
The essential step.
and then gets under that hot, cramped crawl space with mini pipe cutters to physically slice out the old half-inch copper line.
And, I mean, in the past, if you were a homeowner or even a seasoned professional in that specific situation, cutting that copper pipe was the point of no return.
You're committed at that point.
Totally committed.
Yeah.
Because reconnecting a new line meant bringing an open flame into a tiny, highly flammable crawl space,
Oh, wow.
just filled with dry wood and dust. Sweating and soldering copper pipe is an intense chemical and physical process.
It's not just melting metal, right?
No, not at all. To bond copper, you can't just melt solder over it like hot glue. You have to sand the metal completely clean, apply this chemical paste called flux, and then heat the joint with a blowtorch.
While lying on your back in the dirt.
Exactly. And the heat causes the flux to chemically strip away the oxidation, and only then will the molten metal alloy get sucked up into the microscopic gaps of the joint.
Through capillary action.
Yes, it requires a tremendous amount of specialized, gate-kept knowledge to get the temperature exactly right.
Or, I suppose, if the house had been plumbed with CPVC.
That rigid, yellowish plastic piping.
Yeah, that stuff. You'd be dealing with harsh, noxious chemical primers and glues in an unventilated space.
Which is terrible to breathe in.
Awful. And then you're waiting hours for the chemical weld to cure before you could even turn the water back on to check for leaks.
But Claude skips all of that friction.
He does. To beat the heat and get the water back on quickly, he uses a SharkBite push-to-connect ball valve and a half-inch male adapter.
Which is such a game changer.
He specifically highlights his system because there is no sweating copper, no chemical glues, and no expensive crimping tools.
You literally just push it on.
He just pushes the fitting onto the freshly cut pipe, and the connection is permanent and watertight.
And didn't he add a shutoff valve too?
Yeah, he builds in a proactive redundancy by installing that mini cutoff valve right there on the inside of the crawl space.
That is so smart.
If he ever has an issue with the exterior hydrant decades from now, he can just isolate and shut the water off from inside without draining the whole house again.
See, that fail-safe valve is a hallmark of someone who has spent way too much time fixing other people's plumbing emergencies.
For sure. But watching him just shove the pipe into the fitting makes it look like he's snapping together adult Legos.
It really does.
So I have to ask, is it really that foolproof to just push a fitting onto a pipe? Or is Claude's expertise just making it look incredibly easy?
What's fascinating here is how innovations like SharkBite are democratizing skilled trades. The engineering inside that brass fitting is brilliant.
How does it actually hold the pressure, though?
Well, inside the fitting is a stainless steel grab ring with angled teeth. They literally bite into the pipe to prevent it from pulling out. And that's combined with a specially formulated O-ring that compresses to create the watertight seal. By eliminating the need for blowtorches in cramped, flammable spaces, the industry is prioritizing speed, safety, and accessibility.
Over those old gate-kept methods.
Exactly. But the real genius is the compatibility.
Yes, that was the aha moment for me in the source material. Because Claude mentions that this push-to-connect fitting works interchangeably with traditional rigid copper, CPVC plastic, or PEX piping.
Which is a massive feat of industry standardization.
It really is. Like, Claude specifically notes he's using Upon PEX to run the new line.
PEX is great. It's flexible and it expands instead of bursting if the water inside it freezes.
Right, and he mentioned that Ponner's a pro-grade version. He actually had to take a trip to a specialty supply house for it,
Right.
rather than just grabbing standard tubing at Home Depot.
Yeah, you usually can't get a Ponner at the big box stores.
But think about it. Copper, CPVC, and PEX are three completely disparate materials with entirely different structural properties and interior wall thicknesses.
But they share the exact same outside diameter.
Yes. The plumbing industry universally standardized their outer circumference down to the millimeter.
So that O-ring inside the SharkBite fitting doesn't care what the pipe is made of, as long as the outside surface creates a perfect seal.
It totally eliminates the barrier to entry for repairs.
Absolutely. But, standardizing internal pressure lines doesn't mean much if the physical force of yanking a garden hose rips the entire fixture out of the wall.
Oh, man. Yeah, that transfer of kinetic energy leads right into Claude's next hurdle, which is the external mounting.
Because a high-tech hydrant is completely useless if it's attached to a rotting wall.
Exactly. The internal mechanism is only as reliable as its external foundation.
Think about every time you pull a 100-foot rubber hose filled with water. You are exerting significant torque on that spigot.
A ton of torque.
If the fixture is wobbly, you are transferring all of that mechanical stress directly into the wall, which eventually compromises those hidden push-to-connect joints we just talked about.
And that is exactly how invisible, catastrophic leaks start inside your walls.
Yep. But Claude mitigates that entirely.
He does. He completely cuts away the old exterior siding around the faucet area and installs a brand new sheet of treated plywood.
And he's very intentional about the materials he uses there.
Super intentional. He specifically chooses 3/4-inch thick plywood to ensure the new hydrant can be screwed down tightly and remains totally stable.
That thickness is key.
He even notes he plans to paint it later so it visually matches the house's decor.
But using 3/4-inch thickness rather than 1/2 inch provides enough dense material to completely isolate that mechanical stress to the exterior. It protects those delicate internal plumbing connections.
And he applies that same level of scrutiny to the finer details, too. Like when he's prepping the threaded male adapter, he doesn't just use the standard thin white Teflon tape.
Oh, those people have rolling around in a junk drawer?
Yeah, exactly that stuff. He uses something called monster tape on the threads.
Monster tape. That sounds intense.
He points out that it's noticeably thicker and denser than the standard white tape. When you are dealing with high-pressure municipal water lines, that extra density fills the microscopic gaps in the machine threads way better.
Ensuring a seal that won't degrade under constant pressure. It's the difference between doing the bare minimum and actually engineering for longevity.
Which brings up a moment in the video that feels incredibly ironic. Here's where it gets really interesting.
Okay, lay it on me.
Claude is reviewing this product for the manufacturer, right? But when it comes time to mount the hydrant to his new plywood foundation, he pulls out the hardware provided in the Aquor water systems box.
The blue masonry inserts and screws.
Right. And he essentially tells them your screws aren't good enough. He discards them and replaces them with his own wood screws because they offer much better support. He even calls out the company in the video, suggesting they upgrade their provided hardware.
That is pretty bold.
It's like buying a high-end sports car and immediately swapping the tires. Does this DIY tweaking undermine the product's easy installation marketing?
No, I don't think so at all. It connects to the broader picture of practical field experience versus theoretical engineering.
How so?
Well, the manufacturer provides hardware for a generic use case. They likely included masonry anchors because brick or cement block are incredibly common and notoriously difficult to mount to.
Right, they have to aim for the statistical average.
Exactly. But Claude isn't mounting to brick. He has to deal with the specific reality of his environment, which is treated wood.
And his explanation for swapping the screws highlights a fundamental principle of load distribution.
The flange size, right?
Yes, he specifically chooses his own wood screws because they have a much wider flange, which is the flat head of the screw.
Oh, gotcha.
When you drive a screw into wood grain, the holding power relies entirely on the material caught underneath that head. A wider flange distributes the pulling force over a significantly larger surface area,
Creating a wider cone of compression. So it prevents the screw from simply tearing through the wood fibers when you yank on the hose.
Exactly. It underscores this core value that even the best products require critical thinking and adaptation by the end user.
It's a partnership between the manufacturer's innovation and the localized practical knowledge of the homeowner.
So with the internal water lines securely modernized and the rock-solid foundation built, we finally arrive at the hydrant itself,
The star of the show.
which completely reimagines how a homeowner interacts with water outside. Honestly, it upends the entire visual language of a water faucet.
Because there is no protruding brass knob or jagged spout to trip over.
Or snag with a lawnmower. It mounts completely flush to the wall and just features a drop-down flap that protects it.
So it's sleek.
Very sleek. And Claude notes it is inherently vandal-proof, maintenance-free, and frost-proof.
Frostproof is a big deal.
Even though South Texas doesn't face brutal winters very often, Claude points out his previous experience living up north. He deeply appreciates having that absolute freeze protection engineered right into the unit.
Moving the hardware flush to the wall isn't just an aesthetic choice. It physically protects it from blunt impacts and UV degradation, which just destroys rubber washers over time.
Claude also highlights a feature that is crucial for city inspectors. It has a built-in anti-siphon device.
Oh, the backflow preventer.
Yeah, he explains this is designed to prevent backflow, stopping contaminated outside water from being sucked back into the house's clean water supply.
The physics behind backflow and cross-contamination are actually terrifying when you understand how easily it can happen.
Let's break down the fluid dynamics of that for a second. How does water naturally flow backward into a pressurized house?
It all comes down to the Venturi effect and pressure differentials.
Okay.
Picture this scenario. You have a long garden hose attached to your standard outside spigot, and the other end of that hose happens to be submerged in a deep puddle of muddy yard water.
Or worse, a bucket where you are aggressively mixing chemical weed killer.
Exactly, a completely common weekend yard work setup. The municipal water system feeding your house is highly pressurized. But imagine there is a sudden, massive drop in that municipal pressure.
Like if a main water line breaks a few streets over.
Yes, or a fire truck hooks up to a fire hydrant on your block and instantly draws thousands of gallons of water. That rapid loss of pressure creates a powerful vacuum inside your home's plumbing.
Whoa.
And without an anti-siphon device, that vacuum acts like a giant straw. It will literally siphon the muddy water or the chemical fertilizer directly out of that bucket.
Pull it up through the garden hose.
And deposit it straight into your home's clean drinking water supply.
That is legitimately terrifying.
It is. So the built-in anti-siphon device on the Aquor hydrant acts as an atmospheric vacuum breaker. It operates as a one-way street.
Meaning water only goes out.
Right. It allows water to flow out under positive pressure, but the moment a vacuum occurs in the line, the internal valve snaps shut and vents to the outside atmosphere, completely breaking the suction.
Having that sophisticated mechanism integrated directly into the wall unit is a massive upgrade over those clunky brass vacuum breakers that people usually just thread onto the ends of old spigots.
The ones that constantly leak and fail.
Exactly. So the health and safety aspect makes total sense. But the standout feature of this entire deep dive, the part that genuinely changes things, is the operation itself.
How you actually get the water.
Yes. Claude finishes the installation, goes back into the crawl space, and turns the main house water completely on again.
Okay, so the system is fully pressurized.
Fully pressurized.
What?
But when you look at the outside wall, the spigot doesn't leak. There's no handle.
Because it requires a specific attachment to operate.
Right. The high-pressure water is just waiting silently right behind the flush stainless steel plate. To get water, you have to plug something in.
Claude tests 2 attachments, right?
He does. He demonstrates a straight piece with no cutoff and a 90-degree elbow piece with a built-in ball valve.
I'd imagine the elbow piece is way more useful.
He definitely prefers the elbow piece
Uh-huh.
because he can leave it connected to his hose all summer long, turning the water on and off right at the attachment. You just plug it in, twist it to lock, and the water flows.
It completely mirrors the user interface of our electrical infrastructure.
So what does this all mean? We are treating water lines like electrical sockets now. Just plug it in and the power flows. But is this over-engineering a simple valve? Or is it actually solving real problems for the average homeowner?
If we connect this to the bigger picture, it completely eliminates the vulnerabilities of the traditional system.
You don't think it's too complicated?
No, because we aren't adding complexity just to make it look futuristic. We are actively removing inherent risks. Freezing, mechanical parts exposed to the elements, wobbly pipes, dangerous cross-contamination, all of that is gone.
By bringing the vulnerable components inside the thermal envelope of the house.
Precisely. It represents a fundamental shift from viewing a faucet as a mechanical pipe sticking out of a wall to treating it as an integrated, secure home appliance.
It really feels like snapping a wand onto a high-end vacuum cleaner.
And that modularity provides incredible peace of mind. You just twist and pull the attachment off in winter and walk away knowing the system is completely winterized.
So, to recap this journey for you listening, we started down in the dirt under a cramped, sweltering pier and beam house in Texas.
Dealing with the neighbor's motorcycle.
Dealing with the noise, the heat, and a frustrating chore of dealing with wobbly freezing pipes and soldering copper.
And we saw how small innovations evolve that reality. Push to connect fittings, standardizing pipe diameters, critical thinking, adapting hardware to the environment.
And finally, ending up with a stable, secure, plug-and-play water appliance. Claude actually ends his review by asking his viewers if the future to the outside faucet is here.
And based on this deep dive, it seems like a resounding yes.
It really does. Which leaves us with a final thought for you to ponder on your own. If we are now treating our home's heavy-duty water supply with the same sleek, plug-and-play interface as our electrical and digital devices.
What else is lagging behind?
Exactly. What other mundane physical aspects of our homes are currently stuck in the 20th century, just waiting for a similar user-friendly revolution?
We tolerate a surprising amount of daily friction simply because no one has challenged the baseline assumption of how things should work.
Take a look around your house this week. Keep an eye out for the rusty brass knobs in your own life. That's all for this deep dive. We'll catch you on the next one.